Hello everyone. Today we'll be looking on binary search and we're going to find out how this binary search algorithm works. So basically first before we work on how the binary search works, we're going to find out the key points. For the binary search, key point is to find the midpoint. So you're going to find the midpoint first and then you're going to compare this midpoint with the items you're looking for. Okay, we're going to find the midpoint first. When you find the midpoint, okay, you find the midpoint. Okay, from the midpoint, what are the item will be in the midpoint? Okay, what are the items of the midpoint? Items in the midpoint. We're going to compare this item. First things is you find the midpoint. Then we're going to find what is the item in the midpoint. What are the item in the midpoint? We compare with our target items. Okay. If this item is matched, that means you found our items. If this item is matched, that means you found our items, you return the midpoint. But that's if this false, what's going to happen then is these midpoint items can be greater than the target items or target value, whatever you say. If that's the case, we're going to do something, okay? If our midpoint is greater than our target items, we're going to do something, okay? On the other hand, if our midpoint is less than target items, we are going to do something. Okay, this is the main concept of binary search. You find the midpoint. When you find the midpoint, what are the items in the midpoint? You compare with that midpoint item with the target items. If they match, you found the items, you return midpoint locations. Yeah. If that doesn't match, the second condition will be, second condition we're going to look at, the second condition is whether my midpoint item is greater than the target items. If my midpoint item is greater than the target items, I'm going to delete the half of the last half and we'll keep the first half. On the other hand, if that's not the case, then we're going to delete the first half and we're going to keep the last half. Okay? Now, we're going to take an example. We're going to solve and produce an algorithms or pseudocode based on an example. So here is the example. In this examples, before you start the algorithms, you need to remember each and every list is provided they will have the index. Okay, our index we know that it start from 0. So our list got how many items we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means this length of this list, okay, length of this list is 9. So length of this list is 9. Now we're going to give the index. So my index, we know that index start from 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we can see our first index is 0, our last index is 8. Okay. Now the difference with this low index or the first index, we know that is 0 and our last index is 8. If you compare this with the length of the list, you can see the high or our end value, which is 8, and our length is 9, difference is -1. Okay. So our step 1, we're going to say what are our start, or you can see this as a start, or you can see this is the first index, or you can see this is the low, whatever you want to say is absolutely fine, equals 0. And on the other hand, you can see this is high, or this is end index is, we can see, you can say, because if this is the list, 9 and 8 is -1, so it's whatever is length of the list -1. In our case, which is 8 is our high. Yes, that's our high. Okay, 9 minus 1 is high. Yeah. So we got a list. We got our target item, which is 55 in this example. We got our low, which is 0, and we got our high, which is 8 in this example. Now, second in, you're going to find the mid. How are you going to find the mid? I'm going to write down our mid will be low plus high divided by 2. In our example, which is 0 plus 8 divided by 2, and that's 4. That means our mid 1, I'm saying mid 1 because this is the first mid, equals 4. Yep. So we can see on the fourth locations, we have the value for 45. Now we're going to check the third step. We're going to do the third step to produce this algorithm. So the third step is condition and the decision. So we know that it is the condition we need, right? If okay, if list of meet equal target. If this is true, then we are going to return meet. We are going to return the meet positions. We're going to say, okay, item is found and the location is meet in our example 4. Now we'll check this condition. So list of meet is 45 and our target item is 55. Are the same? No, the condition is false. So if this condition is false, what we're going to do is we're going to check the another condition now, okay, which is our condition. Okay, if the next one will be if or target greater than list of meet. Okay, if this is the condition, which is our case, 55 greater than list of meet, that means we are going to delete the first half. We are going to delete the first half. So if we delete the first half, our new list will have 4 value only, 55, 66, and 76, 88. Now in the new list, you can see our low is change. Our low was before 0, and our new low is 5. And our high was 8 at the beginning, and still our high is 8. So that means if we delete the first half, if target is greater than list of meet or list of meet less than target is the same thing, we delete the first half. If we delete the first half, our low is going to change, our high does not change. Now, what is the different relations with the low and mid? We're going to, our mid was 5 before, 4 before, and our mid was 4 before, and our low recent current low is 5. So that means plus 1. The difference between mid and our new low is plus 1. That means if we delete the first half, our low change, it will be, no, it will be mid plus 1. Yes, it was before 4 and it's now 5. That means mid plus 1. Okay. Now, okay. Now in the new list, 55, 66, 76, 88. This is my new list and it's 5, 6, 7, 8. So 5 plus 8 divided by 2 is 6.5. We round it is 7. On the 7th location, we got the value of 76. Now, is this 76 equal target item, which is 55? No. If that's not the no, okay, is it target is it this meet item, is it bigger than the target element, which is right? Yes, 76 is bigger than the target item, or target item is the lesser 76. If that's the case, we are going to delete the last half. If we delete the last half, we can see our high is going to change, but our low does not change. So if we delete the last half, okay, if we delete the last half, our high is going to change, but our low, it doesn't change. If we compare this with our mid was 7 and our high is 6. That means our new high will be mid minus 1. This is the process. We keep on doing it, and this is the algorithms for the binary search. The main point is you find the low, you find the high. High will be length of the list minus 1. Then you find the mid. which is low plus high divided by 2. If it's decimal point, you round the numbers, then you check the three conditions. First one is whether the meat item is it equal to target element. If that's the case, you return the meat. If that's not, if not the case, then you're going to go through like target element, target item, or target is it greater than list of meat. If that's the case, we are going to delete the first half. If we delete the first half, our law will be changing. What will be our new law? Law will be meat plus 1. Else, we are going to delete the last half. If we delete the last half, what's going to have change happen? Our high is going to change, which is meat minus 1. Okay. In our new list, we got the 55 and 66. 55 5 plus 6 is 11. 5.5. Okay, if it's the 5.5, meat is 5.5, round it is 6. If it's the 6, we compare again, this 66 is equal 55, which is our target. It is not. It's not. It's bigger than this, so you're going to delete this. And in our list, we'll have only one items. And if it's the one item, we check this item with our target item. Is it equal? Our target item? Yes, it is. And what's the location? Location is 5. That means this 55 is found in fifth location. That's how it's going to return the value of 5. Okay, that's it. Thank you so much.